In this video, we will show you the principle of operation of sticky applicators and their interaction with the human body. Applicators consist of 5 types of needles placed on a rubber base in the required sequence. 3 of the 5 needle types are electroplated. This procedure is necessary to build up a layer of another metal on the needle everywhere, except for the tip. Needles placed in the correct sequence when in contact with human skin begin to emit galvanic currents. The applicators include needles made of the following metals: ordinary iron, nickel-plated iron, galvanized iron, ordinary copper, and silver-plated copper. Each type of needle is represented by from 12.5% to 25% of the needles on the applicator, depending on the task. After galvanizing the needles of a non-invasive safe form, the applicator assembly follows. The basis for applicators are silicone or rubber for medical purposes. Each applicator has its own unique coloring and barcode, by which you can trace the entire path of the product from the master who made it to the address of the store where it was sold. The needles in the applicator are sticky lined up so as to form a galvanic cell. Each galvanic cell consists of 3 components: an anode, a cathode, and an electrolyte. As an example of an anode, a galvanized needle acts here, and a copper one acts as a cathode. As an electrolyte, the subcellular fluid and intercellular fluid can act. When the circuit is closed, electrons begin to move through the conductor and the load, performing work. The thread in the bulb begins to glow and warm up. Zinc transfers an electron to copper, copper transfers it to hydrogen. Hydrogen is reduced, and zinc is oxidized and goes into solution, saturating the solution with zinc ions. When the electrodes are closed, all the energy of the electromotive force passes into heat. The solution and the anodes will heat up. When the applicator comes into contact sticky with human skin, the heating effect is felt. It is often accompanied by a slight tingling sensation, because the intercellular fluid is a complex colloidal solution that conducts an electric current. It contains various salts, organic and inorganic acids. For example, ascorbic, amber, lactic, acetic. In our case, the needle has the form of a short-circuited element. Cations line up at the cathode, anions and acid residues line up at the anode. The anode transfers electrons to the cathode to the cations leach hydrogen, and the released ion goes into the body. When 2 needles with a different metal coating enter the skin, we create a battery in which the electrolyte acts under the person and the intercellular fluid. The potential difference of such a battery can be calculated from the electronegativity table or measured. The skin is a multi-layered composite electrolyte of various conductivity. The surface of the skin is a conductor consisting of a concentrated electrolyte in the form of sweat. Let's measure the difference in the potential of such a cell. Zinc has a potential of minus 0.76, silver plus 0.8. The potential difference is 1.56 of a volt. Here is a diagram of the propagation of galvanic currents in human skin. Here you can see a diagram of the potential difference between different coatings or surfaces of uncoated needles. Here is the potential difference between the coatings and the base metals of neighboring needles. Here is the potential difference between the coatings of adjacent needles. The use of Lyapko applicators gives the following effects. The first, normalization of regeneration processes, improvement of vascular patency, elimination of edema. The second, effective fat burning due to a significant acceleration of metabolism. Third, immunotropic, immunomodulatory and immunostimulating effects. Fourth, local and general increase in body temperature. The fifth is the normalization of the acid-base balance in the body. Sixth, before the oxidation of free radicals with free oxygen and their transformation from conditionally carbon monoxide into harmless products, carbon dioxide and water, which freely leave the body.